Hello everyone, hope you all are doing well. So today we are going to discuss topic 48 of paper 2, and here we will be discussing enzymes, and we will divide this in two lectures. That is enzymes, we will complete enzymes in two lectures in two sessions. So first of all, we should know what are enzymes. So enzymes are organic substances. These are organic substances capable of catalyzing chemical reactions in living systems. So you can say that enzymes are simply compound proteins acting as a specific catalyst. Enzymes are simply compound proteins acting as a specific catalyst. So this is about enzymes. Now, what are the properties of enzymes? Let me grab it. Nature/properties of enzymes. So enzymes are colloidal in nature. That is, provide large area for reaction. Colloidal in nature, colloids, that is, they provide large area for reaction to take place. They can react with both acidic and alkaline systems. Enzymes can react with both acidic and alkaline systems. Because they are proteins, due to presence of proteins. Thirdly, enzymes show sensitivity. That is, they can be inactivated by all those factors that denaturate proteins. They can be inactivated by all those factors that denaturate protein. As they are a protein, so the process that denaturate proteins can inactivate enzymes. That is how they show sensitivity. Enzymes are thermolayable. Thermo means heat, temperature, that is heat sensitive. Thermolayable means heat sensitive. Enzyme activity can be inhibited. Enzyme activity can be accelerated. Its activity can be accelerated. It can be inhibited and accelerated both by activators. These can be accelerated by activators such as Mn, Ni, Mg, Cl, etc. Enzymes are organic catalysts. Let me have some part. Enzyme molecules are too much greater in size than substrate molecule. Enzyme molecule are too much greater than size than substrate molecule. Enzymes are specific in nature. In enzyme activity is controlled by pH to a great extent. Enzyme activity can be controlled by pH to a great extent. In enzyme lower down the energy of activation. Enzyme lower down the energy of activation. So these are some of the nature, or you can say properties of enzyme. Now moving on, what are the role of enzymes in vital activities of plants? Role of enzymes in vital activities of plants. In vital activities of plants. So first of all, in photosynthesis. So during photolysis of water, enzymes break up electron from water molecule. During photolysis of water, what happens? Enzyme break up electron from water. Enzyme break up electron from water to yield hydrogen and oxygen by using, here which enzyme is used? By using dehydrogenase. What dehydrogenase enzymes breaks hydrogen and oxygen from water. In Kelvin cycle, enzymes like transferase and you can say kinase assist in chemical reaction. These two assist in producing 3 carbon and 6 carbon sugars. So in Kelvin cycle, transferase and kinase assist in 3 carbon and 6 carbon in producing 3 carbon and 6 carbon sugars. They have certain role in respiration. So enzymes such as oxidase, reductase, isomerase, hydrolase, etc. These enzymes are used in various steps of respiration. For example, you can say glucose 6 phosphate is converted into fructose 6 phosphate by the use of isomerase. So isomerase is the enzyme that helps in conversion of glucose 6 phosphate to fructose 6 phosphate during respiration. I hope this is visible. This is fructose 6 phosphate. They have great role in absorption of solute from cells. Let me have it. Absorption of solute from cells. So in the process of contact exchange and carbonic exchange, I have discussed contact exchange and carbonic exchange in previous lecture in detail, how ions are exchanged between themselves using carbonic or carbon dioxide cycle exchange, or using contact exchange. So you must see those lectures to understand in detail what contact exchange and carbonic exchange are. So in these two, various enzymes catalyze the reaction and faster the process. In these two enzymes, faster the process, faster the exchange between the ions. And enzymes are also helpful in germination. So what happens during germination? Starch is first converted into maltose, and here enzyme alpha amylase is starch is converted into maltose during germination in the presence of enzyme alpha amylase, and later this maltose is converted into glucose. So without enzymes we can't imagine of germination. Next, in nitrogen assimilation or fixation, also in nitrogen fixation or assimilation, also enzymes are very helpful. So what happens? Nitrogen reductase, here nitrate is converted into here there is conversion of nitrate into other forms of nitrogen, that is nitrite, I think it's nitrite, and it happens in the presence of nitrogen reductase. So nitrogen reductase is very much important in nitrogen fixation, and it is in root nodules. And enzymes also play vital roles in senescence, ripening, flowering, etc. So enzyme has very much a huge role in every vital activity of plant. So I hope you all understand this. Now, what are the factors affecting enzyme activity? Factors affecting enzyme. Activity. So the first factor is temperature. So what happens? Enzymes are heat sensitive. As in properties I have discussed, that implies are thermohaline, that is heat sensitive. Enzymes are heat sensitive, hence they coagulate at certain temperature. So enzymes coagulate at certain temperature. Even by excess heat, enzymes denaturates. Enzyme denaturates due to excess heat, high heat. Secondly, we have got metals. So enzymes combine with many inorganic ions, resulting in chemical reactions. So enzymes combine with many inorganic ions, that is metals, in chemical reactions. So what happens? Sometimes enzyme activity enhanced and sometimes dependent upon ion. Sometimes these are enhanced, and sometimes in many activity they are directly dependent upon the ion. As such as certain enzymes are activated by Mg, Mn, Co, and these all are metallic ions. So metal also affect enzyme activity. Third, it is heavy metals. What happens? Heavy metals convert enzyme into inactive substances. Heavy metals convert enzyme into inactive substances. For example, heavy metals such as Ag, Zn, Cu, Pb, Cd, etc. This convert enzymes into inactive substances. pH effect. pH effect controls enzyme activity to a great extent. during high pH or during low pH the enzymes activity is inhibited or it is highly regulated. Moving on to fifth one, that is enzyme concentration. So rate of reaction follows the increased let me understand you making graph. So this is suppose enzyme activity and this is concentration. So rate of enzyme activity increases with increasing concentration. Now 6, substrate concentration. So what happens, normally increase in substrate concentration increases the rate of reaction, increase in substrate concentration increases the rate of reaction, but due to after some time at very high concentration substrate restart reaction, but when it increases to very high increase in substrate concentration, then it starts retarding the reaction. So a good level of substrate concentration increases reaction, but very high level of substrate concentration retards reaction. There is also effect of water. Water is very essential for any enzymatic activity. Vitamins, hormones, these are very much important for enzymatic activity. So these are the factors which affect enzyme activities. So I hope you all understand these things. So that is all for today. For any queries, to comment. If you like it, please press the like button, do share and subscribe, and the remaining things of enzymes such as mode of enzyme action, methods of regulating enzyme activity, we will discuss in part B of this session or part B of this lecture. Keep making notes. I always say you in every session that the notes you are going to make are your Brahmastra. Almost every question will be directly from your notes, directly from the topics I am teaching. So keep making notes. That's all for today. Have a nice day. Thank you.